Good morning. All right, I think we should go ahead and get started. So Alexei, thank you so much for running the slides. There are a bunch of them. We have a pretty full agenda today. So I guess without further delay, let's go ahead and get started. Next slide, please. By this point in the week, you should all be very familiar with the note well, but please make sure you're aware of your obligations before you contribute. Next slide. Basically, this is the agenda. It's 2 pages full of stuff. The first part is stuff that needs the least discussion, and then we move into the stuff that needs more discussion. And then we move into stuff that's under consideration for adoption. Has anybody, oh, and there's one agenda bash. The last presentation, Renee reached out to me and said, there's very unlikely that that is going to make it to, that we're going to get through all of this. So he has withdrawn the request to speak, and he will bring his topic to the mail list. Are there any other agenda bashes?
Is there a scribe?
Oh, thank you for keeping me straight. Is somebody willing to take notes in the Code EMD?
I see a very shy hand.
Awesome.
Excellent. Thank you very much.
A shy hand. So the first presentation is going to be from Hendrik. I believe he's the one going to be speaking. Hendrik, would you come to the...
Okay. Thanks, Russ.
Do you have slides?
Yep. It's on the materials. The,
Sorry, they don't
CMP
have
updates.
Okay. CMP updates, algorithm, and lightweight.
Yeah, it's all through the first 3 presentations. Okay, next slide, please.
Next.
So this is about the changes to the CMP update since IETF 112. I managed to reach out to the authors of 4210 to remove the pre-work disclaimer. I did do some checks to address nits from the nit checking tool with regard to outdated historic RFCs. We did clarify the reference to CRL sources based on distributed name and issuer a general name. We referenced to further documents with regard to random number generation. We did open the CA certs support message to also transfer trusted root CA certificates and addressed and security consideration with that regard. And we rolled back a change to the root CA updates support message to not to need to register new OIDs. Next slide, please. So we addressed all feedbacks from Roman, from the area director review. And I guess there are 2 points for further discussion. I didn't get feedback yet from Roman whether the rest was sufficiently addressed. But coming to the 2 open issues, Roman suggested to have a 4210 bis document, though the CMP updates offers quite a number of changes. So the authors are open to do so, but the working group back then decided to go with this CMP updates approach. And finally, if not having the CMP updates approach, we would also probably need to do 6712 bis, because there are also some updates of 6712 in the CMP updates document. So the question is how to move forward with this point. I would like to get some feedback and guidance on what to do next. So yet I didn't receive any concrete feedback from Roman or Russ.
Well, Roman's ready to speak, so let's let him do that.
Ah, sorry, Roman, you're welcome.
Hey, good morning. Thanks for all the work and all the different updates. So the one thing that would help me review all the changes that you made is if you could publish a new document. That would be exceedingly helpful. As to the CMP updates versus kind of doing the BIS documents, we don't need to make a change. We just need to explain our rationale. And I believe the rationale is exactly what you said and what we talked about in the email, which is historically that's not how LAMPS has done the updates, and LAMPS is continuing to follow the same path that it's done before, and I can use that to discuss that in the ISG. I had just anticipated that this would be a bit of feedback on how the document would be done, and I wanted to make sure that we had appropriately kind of had that history documented.
Roman, the other thing is that we thought this was going to be much more modest when we started, okay? And it kind of grew.
Right.
Like we took the opposite approach with logo types, where we actually decided to do the BIS because we wanted to merge 2 RFCs. So, I mean, I think this was a reasonable decision at the time we made it.
Right.
And I think it's just a lot of work to get from here to a BIS.
Yeah, I completely agree. I mean, again, in an ideal world, had we known this, it would have been much cleaner and kind of easier to do the BIS, but that's not where we are now. And so that's why
right.
it was just, we're having the conversation with is good. And for me, the resolution of it is let's just document it in the Shepherd write-up, and I'll have this in my back pocket that we talked about this from the minutes, and I'll use that when we ballot and I get the feedback of why didn't you do the BIS?
Okay. So do you want me to update the Shepherd write-up?
Could you do that? That would be very helpful.
All right.
Because that'll indicate that the working group discussed that versus me saying the working group discussed that.
Okay.
And then if I was being asked about feedback on the .well known, I need to dive into that. I believe it was actually Ben who brought that to the table.
It was Ben. He brought that in the review of CMP over CoAP in the ACE working group.
In ACE, yes.
Yeah, he's probably right. So we took the same approach than EST took, just for being aligned and not having different approach for different enrollment protocols. But I see his point. Having a locally defined path segment in between of some 2 well-known segments is not what yeah, the well-known was built for.
Right. I
So
just
on
found
the
my
next
sticky
slide-
note on my desk from when we talked about it to make that fix.
Yeah, I have some proposals on the next slide, but yeah. You have
So coming back to the updates and these documents, we ended up in similar situation like PCKME. We started doing TC encapsulation guidelines and implementation notes and so on. And then we realized that we have to update and change things. And then we decided it actually is easier to make a BIS document because it's much easier for implementation where everything is in one document.
Yeah.
You don't have to go, oh, yes, implement these, but you always have to implement everything in it here. And that's so it's big. And also the other question is that my understanding CMP is already in use in lots of places where so should we actually start think about progressing it from proposed? I think it's proposed standard now, right? So how about moving
That's
it to
correct.
the internet standard? Should we actually start doing that at some point? And doing that, I think would be much better doing this document.
Yeah. So I had a look into the 4210 and 6712 and talked to the RFC editors and got some kind of XML version. So what the authors think we could offer is just providing an XML, having all the changes done as discussed in CMP updates, and that's it. So that would be kind of a reasonable update or a reasonable effort. Going through all of the sections in CMP updates is probably more than what we plan to do.
So I want to make Tiro say that more slowly. What do you want to change the document to?
The internet standard.
Internet standard? Okay, I just couldn't like.
I mean, this is very brave of you to suggest this. I mean, not saying, you know, it's a bad thing, but
Go ahead, Michael.
sorry.
Michael Richardson. So I think that's a great idea. The problem I think I understand is that I don't think that the work that we're doing here is simply removing things that we didn't implement before, and the stuff that I think you are doing is new work that we won't be able to point to 2 years of interoperation or something like that to be able to get to that. So it would be nice to go that direction, but unless we want the document to sit around for 2 years while people deploy it, I think it's probably going to be
I don't
difficult.
think it's 2 years. I think if I remember correctly, it's like 6 months.
Well, okay,
And
but,
you just
The
need to
point
demonstrate.
is,
the point is
is we could, do we wait and I don't see a reason we can advance later.
yeah. So that's all. I mean, we could. Well, anyway, I think that as you said, we thought this was a smaller effort when we started. I think I agree with Taro that it maybe is that easier to redo this as a BIS. But I don't think it would also be good that we could rip out stuff that we never used when we go to internet standard, and that would also be a good BIS thing if we can get rid of 20% of the document. That's stuff people don't have to review. But I don't think that we can do that. It would be a lot nice. I just don't think we can get there.
Okay, Roman.
Taro says going to the BIS or going to the internet, and I meant going to the internet standard. Yeah.
Right. That was exactly what I was going to ask about. We're not talking about trying to do IS for the CMP updates because that's a no-go. If we want to make a BIS, which would be the only way we could do the IS, that's a whole new body of work. All right, good, thanks. I was just wondering whether we were trying to do something a lot harder.
I think Tiro was trying to get us to do something a lot harder.
So one of comment also, if I understand correctly, we can go to the internet standard later if we have a BIS document. If we actually do a BIS document, and then we have implementations, and after 2 years, when we are ready and we notice that nothing has to be changed, we can then go to the internet standard without making a new RFC at all.
Yeah, you can upgrade it to internet standard without changing the document. Yeah.
So with regard to readability for implementers, with all the erratas and the changes implemented or proposed in CMP updates, it would definitely be much easier to have a BIS document. But yeah, as said, my approach would be to really just do the changes as discussed in CMP updates, and not, like Michael also said, stripping off 20% of the text. That would be just resetting the effort and kind of starting over again. And I, yeah, don't think that this is what is planned.
Yeah, I think, yeah, basically moving to internet standards, it's a lot of extra work for you, so understandably.
Okay, so at this point, I think the plan is to proceed with the document as an update, and if we want to advance, we will do the BIS at that time. Does that make sense? Does anyone object to that way forward?
Okay, thanks, Russ.
Okay, just checking the chat to make sure no one's objecting. Okay, go ahead.
So the second point, as said, it came up, was brought up by Ben during the CMP over co-op review, and as pointed out, the path segment that is implementation specific, pointing at a certificate profile to be used for the enrollment, or a CA to be addressed in the path in between of the protocol portion and the operations portion. Like here we see the arbitrary label in between EST and simple enroll, or in the CMP example between CMP and the initialization operation portion. That was kind of addressed or criticized that this is not in alignment with the .well-known specification. And yeah, Ben clearly pointed out that this wouldn't work out. But Ben, you're on the queue, please go ahead.
Yeah, so I guess the short explanation here is that the well-known path is designed so that there's parts of the URI namespace that are under the control of the protocol, because by default, the URI paths are in the control of the site operator. And it's perfectly reasonable for us to say, okay, we've got this well-known stuff that's part of the protocol, but we want to redelegate some of that back to the operator. But my concern here is that we should not redelegate all of it back to the operator, leaving us stuck without any path for expansion if we need to make new parts of the protocol. And so I don't object to having this sort of arbitrary label or profile label present. I just think we need to make sure we do it in a way that we retain a scope for expansion in terms of parts of the path that are under the control of the protocol still. So the easiest way to do that would just be to add another sort of subcomponent that prefixes what these arbitrary labels will be, and we're sort of only delegating that subtree back to the site operator. But there's a bunch of other ways we could imagine leaving us room for future protocol expansion.
Oh, maybe next slide. So we discussed with the authors some ways to move forward here. So number one is, as we specified it today. Number two is kind of, if we have to move away from that, to do it in the query component of the URI, to specify the certificate profile. Here, this example shows if you want to enroll to a local domain and you want to specify that you want to enroll the LDEF ID certificate profile, then you could do it. Yeah, could use this label to indicate that. To differentiate to some application-specific certificates that may need to be enrolled later on. So this is the second approach, doing it with a query component. The third approach is to switch the operations label and the profile label, but yeah, that seems not to be the logical order. And the fourth option is to move away from .well-known at all, but that is also something the authors wouldn't like to do. So yeah, Ben, you proposed additional options. I didn't fully get them.
Michael Richardson, the mic. I also didn't understand, Ben, what you proposed, which is why I put my hand up.
So I guess if you go back one slide, please. Yeah.
One slide back.
One slide back.
One slide back.
So my proposal, like currently we've got done, the bottom line is the well-known CMP profile label initialization.
Right.
And I was saying that we could do like that well-known /CMP and then add a new path component, but call it P. So we would do well-known CMP /P /profile label /initialization. And adding that extra like P path component or whatever we want to call it is a signal that the stuff after it is a protocol or is a profile label followed by the rest of the stuff.
So I think to be clear, Henrik, on this slide, the word profile label is a label, not a prefix.
Right.
Okay, so just the profile in this case is called profile label, right? Just so everyone knows that's not a literal. And Ben is suggesting that it's a CMP /P/ profile label, and then I don't understand how the initialization is not a label myself, but I guess it's
initialization.
that's the
label.
verb. That's the verb. Yeah. Okay.
Yeah,
right.
The operation specified in the lightbyte profile in this case.
So I don't object to what he's suggesting. And it kind of is interesting to me that that particularly when it comes around to renewing things, that it would be nice to say which thing you're trying to renew. LDEV ID versus some application thing. It would be good to be able to say that, so there's no confusion. I think we've discussed this a lot. We know we have a discovery problem here, but I think that in many cases that essentially someone else is going to say, for light bulb systems that the following profiles are in process, and that there's no discovery. You can go forward one slide again. So I don't like number 2. I don't like queries, but other than that, I have no particular choice. I just wanted to say that I think the query makes it more difficult than anything else. And we can put the /P or whatever it is we want to put in there, Ben. I think that's reasonable, well taken suggestion.
Okay, thanks.
So I think the decision is one with a additional label.
Yep, a well-known label that indicates the next label is, or the next segment is the profile name.
Yep.
Right. Okay, understood. Thanks for the guidance. Next slide, please. So coming to CMP algorithms, the authors addressed, I guess, all of the feedback coming from the working group after 112 and from the area director review. We mainly added in section 7 a table showing all the algorithms and sorted by their cryptographic strength. And we got very valuable feedback from Quinn and his colleagues on the Shake and KMac. And also on the table itself, we added some security considerations. And we managed to also remove the pre-work disclaimer. So I guess the CMP algorithms is fine now from the editor's perspective. So just needing feedback from Roman on the status of the changes.
Absolutely, that's totally fair. Action caught. I've been a little behind. I will re-review it and get it moving. I think from all the conversation we had resolution. I just need to take a look at the actual text. Thanks.
Okay, thanks. So next slide, please. Next slide is on the status of the lightweight CMP profile. So this was not yet reviewed by Roman as we were still discussing on CMP updates. So that is great. We will we did some changes to the light-white profile since 112. We did change to recommended for implicit confirm with enrollment. We did a section on conformance requirements in section 7. We added some clarifications and we aligned with the changes done in CMP updates. So this is mainly it on light-white profile. Next slide, please. So next, so open points would be also to address and implement the changes on the .well-known as discussed before. And from discussions with implementers, we got some feedbacks that clarification on error message protection and the section 7, the PKI management operations support level would be required. So we would like to do that, and yeah, afterwards start into the area director review. So next, I think that's it.
Okay, so with these, it looks like we'll be able to return once you make the changes that we just talked about with the label. The next actions will be with the ISG, and I will update the Shepherd write-up for that. I think that puts these 3 documents back in the pile for the ISG as soon as you have that done. Any last comments on these? All right, thank you for this work, Henrik.
Yeah, thank you for supporting.
And the next document is LAMPS samples. There are no slides for this. It is in Auth 48. Is DKG in the room? Is there anything that you need to share with the group, or are we just waiting for the RC editor to finish?
I'm in the room. I don't know if you can hear me properly. I'm a little quiet. Hopefully that's better.
Yeah, I hear you.
Yeah, so it's in Auth 48. There are a few minor editorial cleanups that Auth 48 has requested, and I'm a couple of cycles into that. I suspect that it will be able to be published shortly. The main changes that they're asking for are, or asking about rather, are fairly small, just textual edits. But they also, there were some errors introduced by the textual edits as well. So I'm just clarifying them right now.
Okay, thank you. The next, that ends the first batch, those things that are with the ISG or the RC editor. The next ones are the certificate-related documents. And Sean Turner's up with the document signing EKU.
One, two, three, four. All right, I think we're good. Russ, are you going to share the slides, or do you want me to?
Yeah, I'm happy to show the slides.
For Alexei or you?
Alexei's got us sorted out.
All right, I'll let you do it. It's 1 slide or 2 slides, I guess, so that'll be pretty quick.
Pass control to you, or
No, keep going. There's only 2 slides, so it's really good. Yep. Hi, this is I guess I need to update the link there, but this is a working group draft for a new extended key usages for document signing. Next. The draft is in the -02 version was published, I think, at the beginning of the month, and it's currently in working group last call. We've received some comments, and we are going to address those before being done what we need to do. Shocking that we defined an extension and didn't indicate the criticality. Obviously, we need to do that. We're going to make it optionally critical. There are some minor editorial issues that we need to fix, which we've got queued up. And we need to add some acknowledgements, and that's it at this point with respect to changes that we have lined up to make for the next version, which I hope will go to our responsible area director. It's in working group last call now. It does not end till, I think, next week. So if you have comments, send them on in. But otherwise, let's yield some time back to the rest of the agenda.
Sean, actually, you're not defining a new extension. You're defining a new
Well-
void to be carried in extension.
Yeah.
So the definition of the extension, I believe, already says optionally critical.
It
You
does
could
say.
restate that, but it's not like you're defining a new extension.
Fair enough. We can do that. We'll just make sure to reiterate that, as this is an EKU, it is therefore by definition optionally critical.
Great.
Thanks for that clarification.
Yes. He said it on the
Ed.
slide as well.
So the next one has no slides. And it's me. We're in working group last call on RFC 3709 FIS. The big change in this document was to get rid of SHA-1 and say where a hash is needed, use the same one that was used to sign the certificate. That way we won't have to do this again for an algorithm change. It is also in working group last call. We have no comments at this point, plus no slide. So please take a look at it. Otherwise, we're going to advance it to the ISG next week. And the next one is Sean again for the clarifications on the NIST curves.
Hey, Russ, on
Or
the 3709,
TFGQs.
on the 3709, I did send in something, but did that get addressed before it went out to working group last call?
I'd have to take a minute to go through my mail and look, but if
Yes.
I'll make sure.
So it's minor. I think the only thing is, I think there was some note. The big one was about which ASN1 syntax to refer to in the title of one of the appendices. So I
Oh
think
no,
you should
that got fixed.
that got fixed. Okay, so
Yeah.
if you fix those, then great.
Russ, sorry, I got a bit confused. On agenda is header protection. Next, I think.
No, I think it's 8410 key usage clarifications. Oh, yeah, what happened was it was originally down in the under consideration section, but the working group adoption completed, so I moved it up here. Did I not repost the agenda?
No. Sorry, I'm struggling to find the slides.
Let me tell you what the name of the slides are.
Yeah.
It's lamps clarifications for ED 255.
Okay, fine.
Can I ask you before you start that, did the draft change? Yes, there it is. Because you still have,
Yes, I sneakily submitted. I submitted a working group draft last night at like 3:00 in the morning. Or I don't know what time zone that was, but yeah. So hey, thanks for adopting this draft. This basically, you can just go to the next slide. So what's in this ID, right? So this text that ought to look really, really familiar to you. It's basically another version of the 5480 clarifications that was published in RFC 8813, but this time it's for the ED star algorithms. The other draft or the other RFC that had the key usage defined for this particular the set of algorithms was defined in 8410. They only specified key agreement and cipher only and decipher only. So basically, the only thing this does is basically said, all the other things that it's not supposed to include. And I think there might be one more slide.
Oh, there are 6 slides.
Oh, there are. So go to the next one. So there's this draft is so short that I think I put the whole thing in these slides. So basically, all we're saying is we added some text. The first two were already there. So basically, what we're adding is the block at the bottom, which basically says don't use any of the digital signature related ones. So we just made those must not to kind of slam the door on those. And that's really it. Because if we're using key agreement, you don't use key encipherment or data encipherment. So it's kind of just straightforward. Now, if you remember at the beginning, I asked Simon why they did this, and basically he said nobody asked for it. So this is just kind of like fully enumerating all of the possible options to make it clear to people the things they shouldn't do. So it's basically removing ambiguity. Next. And you have to do that both for the encryption algorithms as well as the signature algorithms. So it's the 255 ones and the X448 were above. And then you have to do it for the signature ones as well. So you have to do it for the ED255 and the ED448. And so then the only difference is you have to do it for the E certificates, which is what this says. So if for E certificates, obviously you can only do non-repudiation or digital signature, and you may do a CRL sign, and then must not for all the other ones. And then the next one is for the CA, and the only difference is that for a CA, you can also put CA key cert sign. Next.
Wait a minute.
And go back.
I think the you back up one more. Okay, when are you using a CRL sign if you're not a CA?
When you're on like an OCSP responder. This mimics exactly what's in 5480. Or was even in 5480, and now in the 8813 update. So an EE is allowed to set CRL sign.
Oh, it's for the indirect CRL. That's what it's
Yeah.
for. Okay, thank you.
No, it's
I was having a hard time with OCSP because
it's 5:30 our time. So
yeah, no kidding. Thanks. DK.
all right, so
Sean, just out of curiosity, have you reviewed these changes against the LAMP sample draft, which has certificate authorities and entity certificates in it?
I have not, but I will definitely take
but I
that
haven't
on.
tried to compare them.
I'll look. I mean, to be honest, I think most people that are sane usually don't blow this, but there are people I think that sometimes willfully try to misunderstand and make things difficult. So this is mostly just trying to slam the door on that. But I'll definitely take an action to review the examples draft.
I think I got it right, but that one is in Auth 48, and it would be a shame to publish that shortly before declaring that we got it wrong. So,
can you shoot me that link? If you shoot me the link for the Auth 48 thing, I can look at it like before the end of today.
Yep, will do. Thanks.
Awesome. Thanks. All right, so Lexi, I think we're moving to the last slide. And so since you guys have seen all this stuff, and I know it's just an 00 version, I'm actually asking for working group last call now. I think that this shouldn't come as a surprise. It's pretty non-controversial, and basically we're just aligning with a previously published RFC. So I think that that's not an unreasonable request. Thank you.
So what I would like to do is, since we have 2 working group last calls that end next week, is issue the working group last call when those end.
Totally reasonable. Totally reasonable.
Okay. Any objections or concerns with that approach? Okay, thank you. Now up next is header protection, Alexi.
Okay.
Can I
Oh,
sneak
Deb?
in? So we basically have a week to review this before you issue.
No, we will start working group last call in a week, so you'll have 2 weeks after that to review
So
it.
it's 3 weeks to look at it. Awesome.
Yes.
Hey folks, Daniel Kahn-Gilmore here, presenting about the header protection draft, which is work with Bernie and Alexi and myself. We're the editors on it. Just wanted to report back to where we are. I'm going to give a brief recap and then talk about some changes that have been made. We've made good progress on it since the last meeting, so that's good. So to recap, when we were defining this, there were 2 different schemes for header protection. That is cryptographically protecting the headers in either signed or encrypted and signed emails. The type that was specified way back in SMIME 3.1 has not seen much deployment. That's the wrapped message that you see on the left there. You take these things are the cryptographic payloads. These are the data that is within the layers of encryption in the message. And in SMIME 3.1, we said, well, just wrap it all in a message RC822 object. And then we have this other scheme, which is injected headers, which just stuffs the headers that you're protecting directly on the cryptographic payload itself. Next slide, please. The reason that we weren't really satisfied with the wrapped message is that, for one thing, it wasn't widely implemented. There were not a lot of senders that actually did this. And when it did come out like this, a lot of the existing clients that were capable of decryption would present the message in a weird way. It might look like a forwarded message. It might have some strange user interface elements. You might have to click it to save it and then reread it or something like that. Or in some cases, some mail user agents couldn't actually read it at all. The injected headers variant, some of the obscured message headers, that is when you have an encrypted message, they would be invisible to the legacy clients. And we had a fix for that in the previous version that was called a legacy display MIME part that stuffed a decorative representation of the message headers that were obscured into the message body. So it changed around the cryptographic payload to add this decorative part to unobscure, to unhide those header fields for clients that don't know how to interpret this. Unfortunately, what we found was that the legacy display decorative MIME part made the entire message unreadable in one significant mail user agent, which was Outlook. So that's sort of where things stood as of the last meeting. Next slide. And the update is that we have changed the way the legacy display mechanism works for injected headers. Instead of inserting a MIME part, what we do is we modify the main body part of the message. That is the text plain part or the text HTML part that is sort of the first leaf of the message itself. And you can see here how this is a text plain example here, where we just add this legacy display element directly into the text plain part. Next slide. Or if the main body part happens to be HTML, you can see we add it in this particular way. These are both legacy display elements. A message that is multi-part alternative might have two different main parts, one text and text plain and one text HTML. In the situation where you have that, both of them get this legacy display element added. And the rules for adding the legacy display element are pretty straightforward, and they're designed so that when the legacy display element is present, you can tell that it's present, and you can ensure that the legacy display element can be omitted by a client that knows about it. So it's really there specifically for legacy cryptographic, decryption capable clients to be able to render the user-facing headers that that would otherwise be hidden. Next slide, please. With that change, as the draft authors, we've made some decisions. One of the biggest issues with the draft was that we still had these two schemes lying around in it. It wasn't clear what implementers should do. And here we're saying we've made a decision with the legacy display element instead of legacy display MIME part. We believe that injected headers is something that is going to be is going to work for pretty much all the legacy clients. So conformant MUAs must be able to generate injected headers. We're also saying that conformant MUAs may generate the wrapped message, and that all message, the receiving message user agents or mail user agents must be able to consume and render both schemes. In practice, we have not seen much adoption of rendering the wrapped message, but we think with the legacy display and injected headers that even mail user agents that don't adopt, that don't handle the rendering in a deliberate way, we think the legacy ones will be able to at least show the user what they're looking at. And this gives them an incentive to step up their rendering and parsing, because they will now get some security advantages of the protected headers. So must generate injected, may generate wrap message. Next slide, please, Alexa. Thanks. So the way that we got here was a meeting of the design team, which is the group of us who are listed as editors, plus Hernani from the PEP group. We've been meeting about every 2 weeks. We've been working with the GitLab. So we've been doing issue tracking and merge requests and things, and that has actually been pretty productive. We welcome anybody else who's interested in participating to join these meetings. You can let us know either directly on the LAMPS list and say you're interested, or you can mail one of the authors directly. If there's anybody else who's interested in joining, we'd be happy to have you. We are particularly looking for an implementer of a major mail user agent, Outlook or Mail.app, who's interested in this, because we think we are getting pretty close. And we would love to have one of the major mail user agents, an implementer from their way in. So if anybody who's currently in the meeting right now is an implementer of Outlook or Mail.app, or knows somebody who is and wants to get in touch with us, we welcome your participation. Next slide. From the work group generally, even if you're not interested in joining us as we sort of put the finishing touches on this draft, we have updated the test vectors. This document has a bunch of test vectors, and there's a pretty clear, there are different ways you can get access to them that are described at this link at the bottom, header-protection.cmrg.net. If you can, we would love anybody in the LAMPS working group to help us take a look at these. Again, take a look at them with your mail user agent, take the sample messages and route them through various mail transport agents, see how they get mangled, what happens to them. Test automated systems, if you've got things like mailing lists or bug trackers or other systems, we'd love to try to make sure that these mechanisms, we want to understand exactly how these mechanisms interact with those systems. Obviously, we can't do that exhaustively, but we can be more exhaustive with more help from the working group. Next slide. So a couple questions for the working group. I think there's 5 in this deck here. You may recall that one of the definitions in this draft is the header confidentiality policy. So just a quick recap about what that is. When you are sending an encrypted email message and you want to do header protection, not every header is going to be secret, the way that the content of the message is secret. We define an abstraction here called the header confidentiality policy, or HCP, that describes how the mail user agent that is composing decides which headers to protect. We had a couple variants in the draft, HCP minimal, which basically just says protect the subject line and here's how you do it, and HCP strong, which basically says protect everything, but by stripping it out, everything but the from to CC date, we obscure the subject line with ... and we put in new message IDs there. The design team, we have sort of feeling like we need to recommend one for initial implementers to do. We don't want people to have to make hard decisions when they're implementing this. We want them to just have a pretty straightforward roadmap. And we are leaning towards recommending HCP minimal as the initial implementation. You can see there's a link to a merge request that describes that change. The reason we have this HCP abstraction is so that we hope in the future this will evolve, but we want people to have something specific that they can do going forward. If you're going to go from no header protection at all to protecting the subject, we think is a win in terms of confidentiality. Next slide. By the way, these are questions for the working group. We're just, in some cases we have some ideas about what we're going to do, but if y'all have any particular comments that you want to make on these, I welcome comments now. We can also have questions and suggestions afterwards, and of course messages to the list would be great. When you are composing a message using injected headers, you need to decide whether to put the legacy display element in the main body parts as described earlier or not. We would love it in some future world where all mail user agents that are decryption capable are capable of actually dealing with protected headers like this. We would love to abandon injection of legacy display elements. That's the goal, because it makes things much simpler. You don't have to think about them. But the question is, how do we get there? if I'm composing a message, how do I decide whether I need to put in a legacy display or not? The draft currently is silent on how you make this decision. It just says the mail user agent, sets a Boolean flag when it's doing message composition. Do I include legacy or not? And the guidance in the draft, I think, currently says, if you don't know, just set it to true and carry on. So there's a couple different ways that we could get rid of legacy display elements. One of them is that mail user agents could respond to a general ecosystem survey that says, hey, every client that's capable, if we, at some point in the future, we just do a survey of all the decryption capable clients and we say, can they render injected headers correctly without dealing with legacy display? We don't need the legacy display for them. And if enough of them say yes, then we update all the clients in one more round and we set legacy display to false. Alternately, each recipient could try to sort of somehow signal that their mail user agents can render obscured injected headers and don't need the legacy display in that case. But figuring out how to signal, what specifically to signal, is pretty tricky. And if you look at the link at the bottom of the page here, that URL points to some discussion that we've had about what would be some of the drawbacks of signaling, what are some of the things we could try to signal, ways we could signal, what the semantics are. So we don't know whether this draft will contain signaling or not. It will certainly, it could mention that we need signaling without defining it. But we haven't made a decision within the design team about how to do that. Next slide. So one of our concerns about the legacy display elements is that we're not sure how they will interfere, if they would interfere with systems that do command processing. Now remember, legacy display elements only show up in encrypted messages. So this might only be relevant for an automated mail system that uses encrypted messages for its control channel, that might get confused if it sees a legacy display element present. There are not a lot of systems that we're aware of that are out there that do this, that use email as a control channel, but if there are, we want to know. In particular, the Schloeder mailing list is an encrypted mailing list that uses PGP MIME, not SMIME, but the systems that are described here are probably relevant for both. So we've done some outreach to the folks who maintain mailing lists like Schloeder and Mailman, bug trackers, and looking at if there's anything else. I looked at Joker.com, which has an email interface control channel for the DNS, but they don't actually use any MIME-based encryption scheme. They just use PGP signatures inside the message body, which has all kinds of other problems, but we can't really solve that here. Anyway, if folks know of automated mail systems, it would be great, as I mentioned earlier with the test vectors, to test this stuff out. We're particularly concerned about legacy display elements, but we'd also like to know whether injected headers would cause problems on their own with any of these automated mail systems. So something worth taking a look at. Next slide. So for a legacy display element in text HTML, the definition of the legacy display element is basically that it's a div with this special class, header-protection-legacy-display. We think this is relatively straightforward for a composing mail user agent to insert. That is, if you're making the message and you recognize that you've got a main body part that is of type text HTML, pretty straightforward to put it in there. And we think it's actually pretty easy for a rendering mail user agent to omit this if it needs to. We have an example of some CSS snippet that you could slap into your local CSS file for rendering MIME parts if they are tagged appropriately. But we also are aware that HTML and emails may have some issues, and if you are concerned that this this div being injected might cause a problem, we'd like to know about it. We haven't found any case where it does, but that doesn't mean there isn't. So we'd love any feedback from the working group on if they see this as an issue. Next message. Okay, so this is, I think this is the final question that we have for the working group that is pretty tricky. This is, part of this is an issue about user interface and how we represent message headers to the user. So the mock-up you see in this slide is a terrible user interface, but it's an attempt at representing some of the information that we think mail user agents will have. So currently, mail user agents don't mention any levels of cryptographic protection for message headers because there are no levels of cryptographic protection for message headers before this draft, other than the S9 3.1, which was not widely implemented. We think that a mail user agent may want to render and may need to know, even if it doesn't render it, the cryptographic status of each particular header field that's used. So in this message, this is an example here. You could imagine that this message was sent and the entire message, all of the headers, are protected by the cryptographic signature on the message. That's represented by the check mark at the top. But the subject field, as with HCP minimal, was obscured going forward by, so that the subject doesn't appear on the outside of the message. So you can see that in this mock-up that's drawn with a little gold box around it with the lock, just like the message body itself has the gold box in the lock. But the question is, how does the rendering mail user agent know that the header field, which header fields were encrypted and which ones weren't? How does it just compare them with the outside message, or do we need something else? The current text in the draft says that we mark that header field with a cryptographic status that includes encrypted when the protected copy of the field doesn't match the unprotected copy. But as we all know, the unprotected copy of these message header fields can change in transit. That's why we want these cryptographic header protections. And we haven't really defined what counts as a match. So for instance, if white space changes, does it mean now they're different and we should treat it as encrypted? Michael, I see you in the queue.
Michael Richardson. So your UI is not terrible. I was going to say your example would be actually good if Alice was emailing Bob and Frank wasn't someone who knew how to validate the do any of this stuff, right? And so the subject is that Frank sees is, of course, Friday's dinner plans, and thinks, oh, I won't go on Thursday, I'll go on Friday, and some attack on him. And so I think that's
that would be that would be an attack on the signature status, right? Which is different. Here we're talking specifically about whether the header field has been successfully obscured or not. But I agree with you that there is a separate attack on the message signature, and Frank would need to update his mail user agent to be able to get the verification on the headers.
But the point is, I'm trying to say is that Bob would get a notice that says that the subject does not match, right? That's the goal here, because Bob's actually done is validating all of this and realizes that there's something going on. Frank, of course, is oblivious to this because he's just using, his some old webmail system, from 1972, right? But maybe not that early. But I was just saying that's the kind of attack that you're talking about, right? As you say, the unprotected copy can change the transit, and so you want to know what as you say, what is a match, and what are you going to do with that if it just differs by some spaces, which I don't know, some system put in the way, right?
Well, let me. You're raising, I think, a different concern.
Okay, it's a different concern. All right, thank you. That's actually useful to understand.
Yeah. So the concern that you're raising says we want to know whether the message headers were tampered. The outside message headers were tampered with because we want to make sure that we've got the right ones, but we want to know if the one outside was tampered with. We currently don't have any cryptographic status that indicates that, and the reason we don't have it is. Because if your mail user agent can show you the correctly signed message, then including the correctly signed headers, then it will.
Yes.
And doing the kind of debugging that says, hey, somebody fiddled with the thing on the outside is not, I think, for normal users to worry about, right? Like if you say, hey, warning, this thing changed, it makes the message look even worse when in fact you have better security properties. And people, you don't want, when you're sending a message, it to show up flagged just because somebody fiddled with it going through it. The issue that this is trying to raise here is specifically about obscured headers during message encryption. So when your message is encrypted, you might
Right.
not be obscuring out the to and the from or the date, but you are obscuring the subject.
So there is no clear text version of it that was going to see anyway because it's obscured. Right. I get it. Okay.
Right.
Yeah.
And in particular, the concern here is if the sender obscures the subject by replacing it with the square bracket ... square bracket, which is the recommended HTTP minimal mechanism, then obviously the subject has actually been protected because the only thing on the outside of the message is a ... But it could be that the sender did not obscure the subject at all. Maybe they use some sort of HTTP null that's like, hey, we're going to protect everything from signature wise, but we're not going to bother obscuring anything. But some outside mail user agent injected, **, spam, *** in the subject line, and now they differ, right? Or it rewrapped the subject line. Now they differ. Do we claim then that it changed? That because those things differ, it must be encrypted? Technically, it's not a match anymore. Deb, I see you in the line.
Yeah, I know I'm in real life now because I have to stand on my tiptoes to get to the mic again. Anyway, so can you re-explain what protection is on which part of the headers? Like not long and drawn out, but just little. So the whole header is integrity protected, signed?
That's
Yes?
correct. The way this draft is specified, basically every single header will be wrapped by the signature layer, and of course also wrapped by the encryption layer. But some headers may have the same value on the outside of the encryption layer as they do on the inside.
But in
Right?
this case,
Like-
not the subject line.
Right, and that's the
Right.
that's the recommended header confidentiality policy, right? We have this
Okay.
header confidential. The HCP in the draft says when you're composing a message, you need to decide what to do on the outside of the message based on what the original message headers would have been.
So your
Right.
question is what happens when the unencrypted but previously obscured subject line does not match the original?
Well, so in particular, we're saying, look, when you're rendering, the mail user agent probably wants to know which message headers were protected with what kinds of protection. They should all be signed, and some of them could be encrypted and signed. And how do you tell which ones were encrypted and signed when some of them have, I mean, obviously they've all been encrypted, but some of them have also been copied to the outside. It doesn't have the same confidentiality guarantees that people expect, right?
So, yeah, so I'm going to make a comment and then I'm going to walk away. So comment is that I'll tell you that having dealt with SMI messages on a daily basis, that most users aren't smart enough to know the difference between signed and encrypted, let alone with this sort of level of detail that we're talking about.
I agree.
Okay, good.
So
Because it's a fact.
So yes. So the reason that we want mail user agents to be able to reason about these message headers this way is that so one of them is you could imagine some expert mode thing, but we're not going to get into the expert mode thing, right? Where you really do want to show this, a user wants to inspect it, right? You could imagine that. Most people will never use it as you
Okay,
described.
there's 3 of them, by the way. People. Sorry.
There might be 4, there might
Maybe.
even be 5.
Possible.
I don't know.
Possible. I forgot about Alexei.
Exactly. They're all in this room and
He's
in
right
the
in
remote.
the room, Dev. He's right in the room.
I know.
But
I'm looking right at
but the mail user agent might want to know which message headers had this kind of protection because it might be relevant for dealing with the message. For example, when I reply, it might be worthwhile for somebody who's implementing a mail user agent to know that when they're replying, these headers had been obscured previously, and we would like to keep obscuring them.
Yeah, I agree. I just think this is mostly ridiculously complicated for the regular user.
No, I totally agree. The only reason that I've presented this in a user interface here so that people can see the kind of thing that we're talking about, but I generally agree that we do not want to present this to the regular user. But we do think that mail user agents need to be able to reason about which headers had what level of protection.
Yes.
And so
I
this
agree.
is, so the question here is, when the mail user agent is reasoning about the header fields, how does it determine that this header field was encrypted, that is actually confidential, or not? And the text currently says when it doesn't match the unprotected copy. But the trouble is, we know that the outside copy can change in transit. Go ahead, Aaron.
Hi, Aaron. Why, if this is intended for machine, why don't we put it into the encrypted header into like a signaling mechanism or something? Like, why don't we just say, I don't know, encrypted subject, even just true or one?
It's
If
very
you take a-
similar actually to what is in the draft. There is a record of which header fields were obscured and which one were, you know,
Yeah, just
preserved as
design,
is. Yeah. So there, I think part of the question is there is this extra complexity that goes into, you know, an
It
extra
goes-
header, a couple of headers that will go into the encrypted part, and you know, will people implement? I think that's kind of where DKG was going with this.
I mean,
Yep.
clearly the extra complexity adds complexity on the sender side, but this makes it so much easier for like machines to reason about it because the using untrusted data. I'm not the biggest fan of this idea. Yeah.
Yep. So if you take a look at the GitLab issues 25 and 26, there's actually a proposal that's very much along the lines of what you're recommending, Aaron. So I appreciate you taking a look at that and see if you think it makes sense for you. That's sort of the conclusion I came to as well, but I wanted to raise it to the group so we could hear your suggestions. Tiro.
So one of the things you were actually pointing out there that saying that it's actually for the mail users, mail application to know which headers are, you know, encrypted and so on. Is that you were saying, okay, if something was like the subject header was obscured, with not with the ... but nothing here, and you are replying it, do you actually want to keep the, you know, the previous unobscured version that was clear, or do you actually want to, you know, create a new one, or do you want to, and you of course don't want to take the real subject header, encrypted subject header, and put it outside. So,
Right.
so I think and of course we're talking about, yes, we don't not talk about user interfaces, but we actually are talking about to the implementers who are implementing these things. And if we don't give a clear instructions to the implementer saying that don't do this, do that, and follow these rules, they're going to be inventing their own, and which means we're probably going to have a mixed issues again when somebody shows something else and somebody does some other mail implementation. That then we have a legacy display that shows you that the subject that was in legacy display because somebody did implement it wrong. So I think we have to be very, you know, strict on rules. How do we actually say? We are talking about now with the new, trying to get new implementations to follow our rules. So let's make them very strict on what they say, that do this, don't try to do anything else.
I think if I can interject, this discussion also makes me think that, yeah, if we probably should just decide on rules and make them clear. And if we do clear rules, then people will implement them correctly. If we'll allow a lot of leeway, then they will be secondary interesting side effects and bugs. So actually, I think DKG, this discussion just convinced me that your proposal is right.
And completely unrelated to this issue, but actually more generic on this area, there's this group of MARC, which is messaging multiverse or whatever. It has all kind of mail related thing, and I think this is something that would be probably more, you know, in scope with their stuff, what they are doing. There's lots of, you know, mail vendors. There's you know, this kind of people who actually write the mail clients and actually write the mass mailing software and probably sending encrypted stuff, banks and so on. So I would actually recommend actually taking some of these things and try to get it presented in there or something like that. I think the next meeting is in London in June or something like that.
Oh, that's very convenient, considering that I'm local. Yeah, that's a good
Thank
point,
you,
actually.
Can you put that?
It's in the chapter.
Yes, I'll paste it.
Oh, is it in there? I'm not watching. I'm lucky. I
Yeah, it's fine. I'll.
can struggle.
Thank you for that suggestion. I think that's a good one. We should definitely give the MOG folks a heads up, at least that something like this might be coming, so that, you know, we can see how to work with them. So yeah, feedback on the mailing list, feedback on the GitLab issues with these things would be great. I think there's one more slide, but I think it just says questions on it. So I appreciate the engagement and discussion from the group here.
So thank you
Alexis,
very much, design team, for really digging into this over the last meeting cycle. Looks like we have the ask at IETF 112 was give the group a straw man to shoot at. You've done just that. So thank you very much. And I'm looking forward to a robust discussion on the mail list at this point. Are there any last questions before we move to the next presentation? I believe you're not going to talk about the ETA email guidance.
So I'll give you just a brief overview. I don't have slides for the ETA email guidance. There's been one update since the last one, which was just defining a set of headers as being user-facing, which just lists things like subject from to date CC, which are typically presented to the user as opposed to the other message headers. That definition of what is presented to the users directly is useful, turns out to be useful in the header protection document, but we haven't done much else. I am actively reaching out to mail user agents and systems that are used to doing cryptographic end-to-end protection. In particular, different mail user agents, different implementers. I'm reaching out to them privately to ask them for their feedback and thoughts on the end-to-end mail guidance. So hopefully we'll see some more action on that on the next cycle. But that's it for that draft, unless anybody has any comments on it.
Okay, thank you.
Thanks.
Now we're moving to the under consideration for adoption discussion. There's a lot here. The first one is Michael Richardson with the RFC 7030 CSR adders.
Deb, this microphone's actually kind of. Yeah, we should switch them for you. Do you want to give me? Do you want to give me? You want to try that? See if it works this time. Probably not. You need to find my name and click on it and hover and the whole hover interface is real ridiculous. No, there we go. Yeah. Okay, so yeah, so it's a terrible name, so please suggest a better name. That's the most important ask right now. Story so far. So we had a conversation probably last summer, probably at this meeting last summer. We wound up with a virtual interim meeting at the end of August to talk about this problem. I put the links there. If you don't know about it, they're recorded. And we formed a design team. I'll tell you a little bit what the problem is there, but that's the story so far. And we don't have a lot of progress in this, but I'm going to talk about what we have done. So the fundamental problem, does that work? Yeah. Okay. So this is your caution thing there. The fundamental problem is that it turns out that a number of us, particularly in the animal working group, read RFC 7030. We thought, oh, this is some ASN1 that we don't quite understand, so we think it means this, and so we proceeded on that basis. Max Pritikin, who is one of the authors of RFC 8995 and of 7030, was among those who believed that we were correct. And behold, we were not correct. The ASN1 did not do what we thought it did. And so now they're having a conversation of what's going on. Fundamentally, what we need to be able to do as an EST client in Anima, but in other things as well, is we need to have the registration authority say, and this is the subject alt name that you shall use, and any other name that you use will be stricken from the record. Okay, so please request it. Please put it in your CSR request, and that's how it's going to work. And it turns out that we can't do that. We can say things like, please use curve 123 without specifying the actual value of the public key. And we can say a whole bunch of things like that about that kind of thing, but we can't actually say, and you will put this value in the attribute you request. So how are we going to do that? So one way is the kind of simplest way. Right now we have a sequence of attribute or OID, and you get this choice OID or attribute, and this part in the middle here, I don't want to use my hand because people remotely won't see it, but the part in black in the middle, that's what's there right now. I renamed that X type and X attribute simply because in this slide to make it less confusing to repeat the same words. And that's what we have right now. And we seem to believe, you see, it's non-trivial amount of ASN1. And we seem to believe that the X attribute actually would allow us to put a value in there. And we actually wrote code that did that. And, well, it interoperated, but it's wrong. Okay. So this is the simplest version. The simplest version, I think, is that we add a new choice at the top, which has a value. And then we have this new structure at the bottom, which you see now has three elements in it. And there's a thing in the bottom, which is put the value that you want. And I think that's an octet string in the end. But I am not qualified to say that for sure. So that's one version, okay? And this is essentially a conversation in another mailing list as whether it was upwards compatible or backwards compatible. But what I know is that if someone comes along and asks for expects the old response and gets this, that they will be successfully able to skip it and ignore it and not understand it, which may make them fail to interoperate to accomplish their goals, but they shouldn't blow up. So that's one part of it. So this is option A, okay? And this would make, this essentially is a superset of what we do now. So everything that's out there deployed right now would continue to be compliant to this without having to do any other changes. Pardon me? What? Oh, Sean, go ahead. Yeah.
And I just want to say that I think we're putting a lot of stock in the rationale that you have, and that the example in 7030 did not include a value in the attribute. I think we should just fix that. If you look at the thing where you can put a value in, where the attribute thing that you have, like there's CSR adder or OID or attribute. What we didn't include in the example was a value for the attribute. We should just fix that example and call it a day. Like, well, all of this is way more complicated.
Go back for a moment. I think that what you're saying is that our interpretation of the ASN1 was maybe correct, and that we is that what you're saying?
I'm thinking it's right. The example was just wrong because it's got so you have, for the OID, obviously you just include the OID. For the attribute, what you're saying is you want to provide an attribute value back to the client to use, right? The example in 7030 for the attribute just included an OID and not the value, which is incorrect ASM1. So the example is wrong.
Oh, okay. So you're saying that okay. This is also a good result. I'm perfectly happy with that. It sounds
right,
like
because technically, if you look at it, you set the type, the value. If you define an attribute that has no value, you would just send an OID. But most attributes have some kind of value, so you would include the actual value.
So here's the, I believe, the example that may contradict what you're saying, which is that the type might be the algorithm. Yes. The value now is the name of the algorithm, like, ECDSA or ES256, right? Mm-hmm. But at no point do you include the public key, which is the value of that thing.
Right. Well, if you need to do that, then if you need to include something that's not defined, you define a new attribute and use that.
Okay. So
like if you want to slam a subject public key in there, you define an attribute that is subject public key and slam it in there, and there you go.
Okay, so that would be the solution if you needed to do that. That's not what we need to do, but you're yeah. Okay. So
sorry.
So I'm going to engage you on the list with the example that I have from my code. Okay, And I'd really appreciate it if you could say that you in fact believe it follows the ASN that's there.
It does, because in fact there is another RFC that is defined that is used this way, which is RFC 8295. So it's I wanted to provide an entire PKI data back to the client using EST, and I defined it. There's an attribute that's defined for that, and PKCS, whatever it is, I can't remember the value. It's like a PKS PDU. So you can slam the whole thing in there, and you can include whatever values you want. You can actually give the whole CSR you want the client to fire back to you.
Okay, Dan, did you want to add something here at this point?
And I see that Dan is there, so I just want to make sure that because he was one of the authors.
Yeah, thanks. So Sean, you said that the example is wrong. So can you explain why what's wrong in the example?
Let me get to that draft. If you look at
the example has an OID for challenge password, and then it has an attribute of extension request, and it's requesting the MAC address of the client, and then an attribute of EC public key, and it says use P384.
But at no point does it provide the challenge password.
No.
Right,
yeah.
which would be something that maybe someone wants to do.
But S tells you what the challenge password should be. It's
implied.
TLS.
Yeah, it's something else, the TLS union.
So what I'm saying is that in the examples that are in section 4, whatever, that there's one for just an OID, and so you're right, you just provide the challenge password, but that's the only OID. You're just providing an OID, which is saying I'm not giving you the value. If you want to provide the value, you would send the challenge password attribute type with a value. I think that the examples in the draft in that ASN1 sequence, Bob, if you decode that, I think it doesn't actually include the value for MAC address.
That's correct.
So
I decoded it, and I made sure that my code could understand that. Okay. And
so I think
one further forward from that.
Right. So I think what that example needs to have some value set for MAC address. And whether it's a dummy value or actually included value for shipping it back, I think that's what should happen as opposed to going off and defining another choice.
I think Sean needs to join the design team.
I would agree. Okay.
All right. I've been volunteered and I'm willing to do that.
All right. So I'm just going to skip through the next slide to tell you what I think we've just decided not to do. Okay. So the other choice was to basically do something new, maybe even put it at a new endpoint. So you wouldn't say /CSR attributes, but CSR better attributes or whatever. And we would return a completely different thing. And the suggestion we had was actually that, maybe these are the 3 things that we care about having values for, and that if there were more, they would be added later with a new document, not necessarily by an IANA or anything. So I think we've just decided that we're not doing this. Does anyone disagree with that? I'm very happy not to do this. So it means less. I think my code may require no changes, which makes me even more happy there. And that was it. So that was the discussion. This is a squirrel I saw last summer while running. Any other comments? No? Okay, Sean, you will receive email about this.
So you gave him the bag?
I'll be there. I'm just saying, if I get donuts from Tim Hortons,
I did not give the squirrel the bag. The squirrel, in fact, stood in the line and got his own stuff. Right? just to clarify that,
Okay, great.
I will bring Sean donuts in July. There you go.
I'm not in the queue. I'm not in the queue. Sean, did you throw out 8295?
Yes.
Good. I know what that is.
Okay, great. Glad to see we're making progress, although it seems like we might be changing directions a little bit. The next presentation is about post-quantum keys or quantum safe keys. And I'm not sure who's doing the presentation of the people on the draft.
This is the right draft. Is this the NIST one? The LAMPS NIST PKC.
Oh, okay. It's Mike Osborne who's going to do it.
Depending on which draft you're going to show.
Sorry, I was just trying to get, because the list of documents doesn't have titles from the documents in them. It has file names, which is a bit.
This is quantum safe keys. Okay. I thought I saw, there he is.
So first,
Over
hi
to
everyone.
you.
This is my first IETF meeting, so it's a pleasure to meet everybody and let's say understand a bit how things work here.
I think you need to get closer to the mic.
Closer to the mic. Okay. Okay. Just to say, it's my first my first meeting here. So we've been working in this area for a while. It's going to go into let's say maybe we go to the first slide essentially. So this is a piece of collaborative work around post-quantum crypto. We've been very active in this domain with some collaborators. The challenge that we've seen is that the NIST, when they were looking at standardizing this, and the round 3 or the fine list should be announced this week, is they really haven't looked very much into how keys are serialized. For the competition, it was just required to have a single blob. That was what the API required. And so there wasn't really much thought put into managing how keys are serialized and identified and things like this. It's kind of, a lot of people have picked up on it to say, okay, for example, you can not having to look at the keys and just identify it with OID is very nice. There's no more passing of keys. It's simple. However, there are problems with that. Sounds really nice in theory, but I'll come on to why that's not a very good practice. If we look at the structures of keys, so keys, it's an implicit structure now that's going to depend on whichever of the algorithm strengths is selected, which version of their algorithm. There have been lots of versions already going through the different rounds. And there are a number of hardware-related alternatives proposed. So you can, there's a lot of there's just a lot of different algorithms that you would have different IDs that will need to be tied to some form of key format. So lots of variants. If you start tying those variants to hybrid schemes, it's just a combinatorial explosion. So we also look at Open Quantum Safe. We have a test server up with over 1,000 hybrid quantum safe and classical key formats, and that's only a fraction of the ones we could have implemented. So, and we have lots of problems with interop testing, just because these things are evolving, these things are in the field, and we just need to figure out how to manage the complexity. If you can go to the next slide, please. As I mentioned, it's nice in theory to have an implicit key format tied to an OID, because people who design algorithms or security, then they say, okay, there's no parsing involved. You remove all of the parsing vulnerabilities that you can build in. In practice, as I mentioned, these algorithms are deployed. We've been deploying quantum safe algorithms for over 3-4 years now. We see that legacy systems simply do not support the size of the keys for many of the new schemes. This is, for in our example, I work for a large IBM, large machine manufacturer. Our largest platform cannot support even the smaller sets of keys for a lot of the algorithms. So there's a lot of legacy out there which is just going to struggle. And it's this aspect of getting keys safely to algorithm engines, which is kind of not really looked at from an algorithm design perspective, but from a secure implementation perspective is really important. And that's where most of the problems are. So actually, most of the schemes proposed at NIST, they detail compression schemes, so in a very unstructured way. And we've just found in practice that these schemes are required. So we're trying to avoid a bit the mistakes in the past. I understand it's very compelling OID key format, very simple, but we know that we're going to have to compress keys. We know that there are going to be evolutions of algorithms. And so what we're trying to do is design a format that handles that complexity in the future, rather than take the simple option and then just add then these exceptions as and when they come. That's a bit the problem that's happened in the past with other algorithms. You can go to the next slide, please.
Yeah. Would you like to take questions now or at the end?
Well, however it works process-wise. This is my first meeting, so
It's your choice, basically.
yeah. I can take them now.
There are
Yeah.
4 people in the queue.
Oh, sure. Done. Yeah.
Michael Richardson here. So, so you're telling me that basically, if I present a certificate to some systems, that they just blow up because it's just too big for them. Is that what you said?
There's actually more on the private key side. So private
on the
key,
private key side.
and so there are some compression schemes for the public key, but absolutely, yeah.
Okay, I wondered if we should just start issuing certificates, with some bogus extension that has a megabyte of random data in it, just to kind of
To test them.
to test out some to grease out the systems and see who's going to blow up, and kind
Yeah,
of
there have
present
been-
some stuff like that would break some things intentionally.
That's exactly what some experiments have been done by certain companies. They have actually
Just put some junk in.
exactly
Yeah.
to see where things in the internet break. Exactly.
But that you're talking about private keys, and I think that you're now, as I understand, you're now really talking about hosts or systems talking to their cryptographic engines, their physical hardware engines. They can't even get the private key across that interface.
Well, essentially, if you want safe algorithms, you need to get the keys safely to them.
Right.
And essentially, so there's no point having very strong algorithms unless you manage the key.
And those interfaces, which I think are somewhat hardware, are breaking as well, is what I think you said.
Absolutely, they
Yes,
just don't
okay.
fit. So also lots of protocols. Any protocol where you need to transport keys, any kind of like internal framing mechanisms for key movements. Anytime you want to use
Okay.
whatever. So it's just a whole lot of legacy, which is going to be very challenged, purely with quantum safe keys, let alone hybrid related things.
Okay. Sean?
Okay, so one of the problems that ended up happening with compressed keys before was that there was IPR. I assume that there is no IPR with respect to any of the schemes that you are proposing.
So let's say we're contributing to some of the candidates, and most of the candidates, certainly the ones we propose to, are all IPR free. So it's less about the compression schemes. It's more about marking, or let's say the framing of keys, or let's say being able to identify when you have a compressed key and things like this. It's not how these things are compressed, more how they are communicated that we're concentrated on. But certainly, what the key compression, I think that's a decision for NIST at the end of the day, which in terms
Right,
of
I think,
yeah.
So I think NIST is. I just want to say that the last time that this came out was for elliptic curve stuff, and one of the reasons why no one would touch it was because we couldn't get good terms. And so I think if we're going to adopt a scheme, we just have to make sure that we understand that there is or isn't. And I think what you're saying is it's not my problem. It's whatever agreement NIST comes up with the competitors, and that's great. Thanks.
Actually, what I'm saying is important to be able to manage compressed keys. Whether or not which schemes and which compression techniques are used, that's something else.
Yeah, I'm not sure this is the right way to go. Most of the schemes that have some compressed alternative are different schemes. They are not compatible with the uncompressed version. You can sometimes do all sorts of things with secret keys, where you pre-compute some stuff. You can expand the lithium's matrix, but that's all on the secret key side. And I don't see why you would need that for public key representation.
Yeah, it's less so. There are a couple of schemes that have public key compression, but this is more essentially about more related to the private key and being able to identify essentially what key. So it's more about the management of the private keys that this is.
So you want to do private keys, okay? Then you also still need to be careful that the compressed variants of Rainbow. I mean, Rainbow is dead now, but the compressed variants are not the same scheme as the.
Yes, of course, yeah. But the schemes which currently NIST are looking at the compressed alternatives to those, with exception of Rainbow, they are just artifacts of how you can compress a key in a way that is compatible with an uncompressed one. So you have a trade-off with key expansion versus key size.
And then the other thing, I expect all of the SHA-3 variants to be murdered by NIST very soon. I have the understanding that none of the submitters intended for any of the AES or SHA-2 variants to actually get standardized.
There's two things. One's being standardized, one's being used. So there are a lot of schemes, including Rainbow, for example, was already being used, and also dilithium and Kyber. They are used already in a number of industry things. This is a bit the problem that you have with anything that's about to be standardized, because standardization takes a long time. They start to be used. You start creating legacy. Then, in order to manage complexity, you end up with standards which are very evolve very awkwardly. So all we're trying to do here is, let's say, for this aspect, look at, we know what's coming, that we will need to use these compressed keys, which take out of the equation. It's really about how to manage those appropriately and safely.
Okay, then.
The management.
Yeah, one last question with regards to the symmetric primitive that you use inside really makes obviously all the test vectors different, etc. So that's a different algorithm. What is the problem with just assigning more OIDs?
The size, purely the size. Even it's so one is managing the what an OID actually references to. The other one is then how you handle and manage non-expanded key formats. How you actually manage and understand what you have.
Okay.
Otherwise, we just want to, let's say, reduce complexity around passing of private keys. No.
So thanks for bringing this to the group. This is Daniel Gilmore. So it sounds to me like this is just about private keys, right? You're in this presentation, you are not talking about trying to represent public keys at all here. That the main concern you have here is about private key representation. Is that right?
Exactly. It's more so the focus is really on managing complexity, and it's really focused exactly more on the private key side of things. Yeah.
Right. So yeah, it's useful to have that clear, because otherwise we're going to have people going off about public keys as well.
Okay.
Which may be an issue, but we can tackle it separately. So my question for you is this: if an implementation is choking on private keys that are too large, presumably that implementation doesn't even have an implementation for private key for that algorithm, because it can't, because the key is too large. So where is the issue with just saying, when you're ready to handle keys of algorithm X, make sure you can handle keys of the appropriate size for algorithm X? I mean,
it's that when if you're ready,
upgrade anyway.
Yeah.
Right. As long as there's an upgrade to handle algorithm X, presumably that upgrade, you also tackle the parsing structures that had hard-coded limits and extend those hard-coded limits. Why is that?
Because there's a lot of legacy you won't be able to handle the uncompressed keys.
So you're saying that there's like you're concerned about parsing layers that are algorithm agnostic. That are shipped independently of the
identification and management thereof. So at the end of the day, one of the goals is essentially to provide the smoothest path for a transition to a quantum safe future. And that essentially means, in some ways, it's also the widest adoption. And if I look on the systems that we have worked on, is essentially there are limits which make it very difficult to expand certain system parameters to handle private keys. So it means if you can't do that, then was maybe one of the NIST alternative quantum safe algorithms that will be used, but it will prevent a lot of systems from being able to use quantum safe crypto.
Can you identify the specific parsing layer limits that you guys have run into? I mean, it sounds like that you're talking about a parsing layer that is independent of the algorithm implementation.
Yeah, it's less the parsing layer. So essentially, if you need to transport a key to an algorithm engine somehow, I mean, at some point you have to. It's any framing, any protocol where you're actually moving that key, essentially, wrapped or unwrapped or whatever. It's
Can you identify one of the implementations that has these limits, just so I can get a better sense of the kind of limit you're talking about? Like, is this like an OpenSSL issue? Is it a NSS issue?
It's anywhere where you're kind of using slightly more secure methods where you're not just using a file to save the key somewhere. So yeah, it's any without going to. Maybe we can respond with a list of systems that we've come across.
That would be great.
Yeah.
I think having a concrete list to look at would help to characterize this, because I don't fully understand the problem without looking at some examples, I think.
Okay.
Thank you.
You said that you were worried about legacy systems not being able to handle these keys, but legacy systems aren't going to be speaking a PQC algorithm anyway. So why do you care that they can't get
Well, legacy
a key that they're not going to
platforms.
be able to
I
use?
mean, legacy platforms, not systems. So essentially, any if you build platforms or you build systems that actually you can't actually manage keys just because because they're too large for the parameters of the systems and the protocols you've used. I'll give you an example, like a mainframe platform. Sounds like a very large platform. So there's a lot of keys you just can't use, just because you can't transport them securely. They're too large, outside of the design characteristics. So if you want for an existing platform or let's say EDI system or something like this, where you do need to transport keys around, and
But isn't that platform going to have to be changed to support?
Well, that's the point. No, not if you use compressed keys. If you use compressed keys, then you trade off the size of the key with the ability to actually uncompress it or regenerate it. So it just means that you're able to, a lot of systems where the uncompressed keys you can't fit, you can use quantum safe algorithms.
Right.
We have any more questions or?
No, nobody in the queue at the moment. So
Okay.
You want to move on?
Yeah, sure. Yeah, so that's the goal essentially. I mean, we've seen how difficult it is in applications, and it's really about making sure that the PQC or quantum safe algorithms can be used by the largest number of applications, and that's invariably going to mean a lot of them are going to need to use either schemes with very small keys, and there's only really one, or use compressed keys. The other thing is, a lot of this, as part of this NCCOE effort to sort of facilitate the migration to quantum safe schemes, if things tend to happen sequentially and in an uncontrolled way. So actually, the more that we kind of experiment, and that's what we've been doing essentially, experimenting with interoperability and understanding how to use these things in real systems, the more we can do in parallel, which is why we kind of, it's a bit early, but a lot of people have said, why don't you wait until the final NIST selection and then work on this? And that's because actually there are some things that have fed back into the different schemes. So for example, in this piece of work. So it's really just about widening the aperture for systems to become quantum safe, actually. The approach is really just to think about the complexity ahead of time, not go for the easy case and then add stuff on when things don't fit. So it's really about, also there are various ways to actually to come up with OIDs for, so how you create OIDs. So in terms of, whether the whole parameter set gets represented by a key or not. I mean, with these, with certain of the lattice schemes, they are matrix, so you can actually put the matrix sizes in the OIDs and things to simplify, essentially to simplify stuff. And then so this is the identification algorithm approach, and then the high level, just the high level API considerations essentially. The optional choices recommendations for when you'd want to use a compressed key format and when not, what the trade-offs are, stuff like this. So generally a kind of like a guideline for the usage of private keys in a kind of a future-proof way for next generation algorithms. Go to the next slide, please. I think this just kind of like says or suggests how we think we can arrive at such a scheme. So it's kind of whether this is informatory or whatever. Just I think it's not something that there's got a lot of wide visibility, just because a lot of companies have been waiting for some final NIST standards, essentially. So the problems around private keys. This thing with interoperability and stuff. So we've already had numerous interoperability challenges because as algorithm evolves, obviously the private key formats evolve. And if you can't manage the transition, so say we have to tweak a parameter because of a security breakthrough, for example, in Rainbow, then we have to sort of tweak the keys, the algorithm a bit, which means the keys change. So yeah, in some systems, if you're using the older keys, you might want the ability to migrate to using the new algorithm, but with the old key. That's very difficult. It's very messy and complicated if it's just an implicit serialized blob. We have shared this with the cryptographic community. We have received feedback from a lot of the scheme authors. We are ourselves authors of some schemes. And the approach has already identified a number of challenges, or caused actually some of the specifications to be updated because they weren't particularly clear in the formats of private keys. So it's already a couple of years old, this work, and I think we're just looking for the best place to give it to sort of help the community with awareness in this area. I think next slide, please. And so, in terms of what if you need a structure to be able to manage things like uncompressed and compressed, it's what does that structure look like? What are the trade-offs when it comes to complexity in parsing? Obviously, we want anything that needs to be specified needs to reduce any potential vulnerabilities. So that's a debate because there's many ways to do that. There is complexity. It's just a question at the end of the day where you want to manage it. You can't ignore it. It's a lot of alignment with other activities. The whole set of separate questions around hybrid, which just amplifies the problem, essentially. Yeah, and then there's things like, as I mentioned, scope adjustment. We've originally created a document for all of the NIST round 3 finalists and all the alternatives, and happy to debate what scope or what else should be in there in terms of. There will likely be schemes which drop out when things are announced next week. There will be alternate schemes brought forward for round 4. So all things we're happy to discuss. What makes sense? What best serves industry in terms of having some clarity going forward about how keys should be managed. Private keys should be managed. That was all I wanted to say. I think that was the last slide. Let's see, as a question, I guess.
I think I'm in the queue here. This is Daniel. So I had one other question that I think wasn't actually covered here, which is whether you are looking at stateful signature schemes as well. It seems to me that stateful signature schemes would require even more infrastructural overhaul than just expanding key fields, key sizes, right? Are we excluding stateful schemes from this? Because if stateful schemes are included, then it seems like there's gonna, whatever transport, plug-in mechanisms we're talking about are going to need an overhaul anyway, right?
That's correct. That's a scope question. So again, that's up for debate or discussion. I mean, there are a lot of complexities because of you need a feedback mechanism when keys are used. You're absolutely right. It is another layer of complexity. Using stateful hash-based signatures, but really open to whether if they should be in here or not. It's kind of
So my observation is just that if you're going to be dealing with a system overhaul for stateful signatures, then surely that happens at the same layer that widening the field for secret keys or private keys would be done. And this strikes me as injecting a fair amount of complexity into the overall interoperable ecosystem for the sake of not touching a few implementation layers, just to widen the width of whatever, wherever those limits happen to be. And if you're going to have to tamper with those infrastructure layers to handle stateful keys as well, then I would prefer to have less complexity in the interop part of the systems. That's just my observation.
Yeah,
Thanks.
yeah. Complexity will come. Like I said, the aim is to manage it. You can't ignore it. And it's a very good point with the stateful hash, because this is this adds a really very different level of complexity. So this again is a scope thing. Very, very happy to sort of have that debate. What you think makes sense, but you will not get away from complexity because systems will need compressed keys. It's really that simple. Question is when you face the problem, whether you're trying to manage it up front, how it should evolve, or you kind of evolve as these things come up. That's all it is. That discussion.
Okay, Julian.
Yes. Hello, everybody. So maybe that's my first attendance to the meeting. So hello, everybody. I'm Julien Pratt. I'm working for CryptoNext Security, so dealing mainly with quantum safe algorithms. And my question is about the opportunity of defining all the compression formats, because I think that there are as many compression as there are implementations. So isn't it a little bit tricky to try to be exhaustive and to define the parameters, well, as you made in your draft RFC, I mean, with many details, because I think that there will be more tricks that will come later. And I think it's more a kind of the work of NIST to define the key format than our work, I guess.
No, actually, we spoke to NIST and they suggested here. Yeah, but it's again a scope thing. So we also believe that compression mechanisms parameters will evolve. So how are you going to manage that? You just at the end of the day, with a million OIDs and sort of a million different specifications to go and look at. That's one way of doing it, but we don't think it's a good way. So you got to start somewhere. It's just again, it's just how you want to manage the complexity going forward for something that is complex. Just because things are much larger, things are evolving. It's just an attempt to help manage that journey going forward. And what you're talking about is scope. So in terms of when things change, what to do when things change. I mean, the point is that round 2 algorithms, round 3 algorithms are already in the field and being used. So it's kind of these things already need to be managed by the organizations that have rolled these out. So then comes along a kind of the NIST standard. Then there'll be probably I suspect there'll be some changes in the parameters, so that'll be another one. And it's kind of, and I suspect after that, all you need is something like a breakthrough on Rainbow, where the lower parameter, lower strength algorithms get broken, and then you need to ratchet things up, so they'll change. And that's kind of just gonna amp. Unless you manage it, it's going to be difficult. That's all I think we're trying to communicate.
Okay, Scott.
Okay. About stateful. This is Scott Fleur. About stateful based moving private keys for stateful based signatures. That requires a whole bunch of other problems which need to be addressed. I believe this is way out of scope for this draft. It would actually, somebody would have to sit down and work out all those issues separately. Totally independent work. Thank you.
Yeah, I believe you need a protocol. You need to define protocols to manage stateful hash signatures properly and securely, and that is not really what that is a different scope than at least the simple cases for the for the stateless themes we're looking at. I agree, but.
Okay, I'm closed the queue, so we're going to wrap up this presentation, continue the discussion on the mail list, and try and squeeze in one more presentation in the remaining 5 minutes, which is Sean, who's going to talk about how to put post-quantum keys into certificates. It's very clear to me at this point that we're not going to get any further in the agenda, and we'll have to schedule a virtual interim. So Tim and I will put together some kind of a poll to figure out when to do that. And Sean, over to you.
So, all right. So, hey, so this is an individual draft that I'm requesting the working group to adopt. There may be one or more of these because this is specifying the algorithms for, an RFC 5480 like our internet draft that hopefully will move to RFC status, which specifies how to put post-quantum chem certificates, keys in certificates. Next. And so what's in this, right? Basically just, it's actually pretty short. There's not a whole lot in there because basically all it's specifying for the PQ Chem stuff is the format for the subject public key. So it says, what OIDs are we going to put in there? We're not defining any. We're going to take what NIST gives us. Parameters, none. We're just going to use an OID to specify whatever the two security levels are. Leave it at that. We're trying to learn from the complexity that was, I think, hampered the deployment of elliptic curve with all the options that we had. We're just trying to keep it simple. The key format, just a bit string. Again, if you remember, the elliptic curve had the first byte, had some weird values to tell whether it was compressed or hybrid or whatever. We're just going to not expose that. Let the crypto standard specify that, and let the crypto engine deal with it. Key usages, just set one. It's the only one that really applies. Get rid of everything else. And again, in this format, this is the one key, one certificate option. Next. We got a couple of questions, whether to do one or all. When I was writing this, the idea was that we were going to put all the PQ Chem candidates, and then the last time we talked, it was like, well, what about all the signature candidates too? Panos asked me, he's now one of my co-authors. I guess that's something else I should mention, is that I got co-authors that actually implement stuff, so it's not just me writing it. So I got Panos and Jake from AWS and Boz from Cloudflare to look at this stuff. So we could put all of them in there. We could put one, and Panos is like, why did you do that? And I said, well, that's kind of what we did, and like one-stop shop is really nice. But that's not really the strongest of recommendations. So I think we can kind of take it to the list to decide whether we want to have one draft with all of it or multiple drafts that would allow things to progress differently. Panos has a bunch of reasons for why we might want to split them. So right now it just has one, and luckily NIST hopefully is going to pick next week or by the end of next week, and we can just rev a version and put some values, quote unquote, in there. And we want to prohibit some key usages. That's it. Next. I guess I double up the slides. What do we want? Working group adoption. Thank you. I know that was super fast. Hopefully Deb got some of that.
I'm glad to hear the use one OID to define the algorithm and parameter set, and then just put an octet string with the key in it. That seems straightforward and is going to eliminate a lot of the silliness that we had with, signed bits for DSA and so on. This I think is a good thing. Mike, you have some comments? Mike? We're not hearing you, Mike.
No.
Still not hearing you, Mike. All right, so let's go to Panos and see if Mike can figure out his microphone problems.
Yeah, can you hear me okay?
Yep.
I just wanted to make the point that, for for one scheme per draft, because I think it's easier for an implementer to follow and comply. It's easier to review in the list, and also camps and signatures have different uses, right? So probably it's cleaner to have them separate. These were my basic arguments for a cleaner one draft for CAM, one draft for signatures. Thanks.
Okay, Mike, we're out of time. Does your mic work? Not hearing you.
I should say that I know that Mike's got some other drafts in flight too. We are working together to make sure that we provide the same answer, so that what his draft specifies and what this draft specifies at least line up from using CMS.
We are out of time. Like I said, we'll schedule a virtual interim to hit the rest of the agenda. Thank you very much. And clearly we have a lot more to do coming. And NIST is expected to make their announcements by the end of the month. So we should know in the next week or so. Thank you very much. And for those of you in Vienna, safe journey home. Thank you, Alexei, for punching the slide buttons.
Thank you. Bye.
I have no idea how constraints work, but I guess. So basically, yeah. I mean, if it's going to be horrible,